Earlier, we talked about how a linear system can be encoded as a matrix multiplication equation. And so here's the example that I showed you before. So this is what we call a linear system. That's just a fancy way of saying a set of several linear equations that have the same variables. We call it a linear system. And it can be rewritten as this matrix equation right here, where A is what we call the coefficient matrix. It's obtained just by extracting the coefficients from the system and writing them in a matrix. And so in this Aij, so the ijth entry of A, is the coefficient of the jth variable in the ith row. And so it's just, you can see just by staring at it how it matches up. We have 2 goes to 2, -3 is -3, 1 is 1, 1 becomes 1, 2 goes here, -1 goes here, and so forth, right? So then we also have the unknown. So this is the unknown, or the vector of unknowns. And then we have the constant, or vector of constants. That's this guy here. Okay, so in the case when, and then the equation that shows how the linear system is equal to the matrix equation is this one right here. So if I write A times V, and I do the matrix multiplication, then this vector dotted with this one gives me the first entry right here. The second row dotted with this vector gives me the second entry here. The third row dotted with this vector gives me the third row right here. And then if I look at these are exactly the lines of this linear system right here. And I need the first one to be equal to 1, so that's this. The second one to be equal to 5, so that's this. And the third one to be equal to 2, and so that's this. And so it is actually this precise equation right here. So in the case when B is equal to 0, we say the system is homogeneous. And then there's one other thing that we can do with the system that will help us when it comes time to actually solve the system, and that is to look at the augmented matrix. And this is just a streamlined way of writing the matrix equation as a single matrix. So what we do is, so the augmented matrix, which is A bar B, and it just consists of taking the matrix A. Let me grab a copy of it here. And then taking the vector of constants. Let me take a copy of here and join it. Whoops, I guess I missed the 1. There we go. And then we draw a line here to indicate where the equal signs sort of go. And this is just sort of, well, we'll see, it's a handy bookkeeping tool for when we try to solve this system. We'll see how to do some transformations or moves. We actually call them row operations to this matrix, and that will help us find the system.